So this is question 6 from the 2017 Matt. You need to pack several items into your shopping bag without squashing any item. Suppose each item I has a positive weight Wi, a strength Si, which is the maximum weight that can be placed above it without it being squashed. For the purposes of this question, suppose that the items will be arranged one on top of the other within your bag. We will say that a particular packing order is safe if no item is squashed. That is, for each item I, Si is at least the sum of the Wj corresponding items J placed above them. Right, okay, long-winded way of saying the obvious. For example, suppose you have the following items packed in the order given. Well, the bread's going to get squished, yeah, as it says. If you swap the apples and the bread, then it is safe. Okay, which of the other 4 orderings of apples, bread and carrots are safe or unsafe? Well, we have to have the carrots at the bottom. So, well, just that in itself means there aren't going to be any others. Does it ask us to explain? No, it doesn't. But yeah, I mean, if we've got the carrots have to be at the bottom, and they've already told us the result of the 2 permutations that run off of that, well, we can't have anything else. So we can just say none of them. They don't want an explanation, so let's not give them one. Part 2, consider the tactic of packing the items in weight order with the heaviest at the bottom. Show by giving an example that this might not produce a safe packing order, even if a safe packing order exists. Okay, by giving an example, or we just make something up, do we? Is that what they want? Just make it up? Like give our, well, we can't, I mean, we're not going to be able to do it using apples, bread and carrots, are we? No, because if we did those in weight order, that would be safe. So we must be just making something up off of this. So say, well, let's just do 2 items then. So if we got item A and we want to put the heaviest at the bottom but still have it getting squashed. So let's say, well, that one's the heaviest then. So we'll say that the weight is equal to 4. And we'll have something that is lighter. Let's say the weight is equal to 2. So we'll put in the heavy thing at the bottom, but we need it to get squashed. So let's say the strength is equal to 1, because that would mean it would get squashed. And then we can say for this one, which would have to be able to stand up to it, let's say strength is equal to 5. So if we had A over B, then B has strength to hold up A, so that would be fine. And if we got B over A, which is the heaviest one at the bottom, then it fails. So that's all they wanted. Okay, that seems a bit odd. Part 3, now consider the tactic of putting the items in strength order with the strongest at the bottom. Again, show by example. Right, so another one, we just make something up then. Again, this is just going to be blindingly obvious. Right, let's take slightly more extreme values on these, I don't know. So let's have something, so we want to have something which is the strongest at the bottom, but it still doesn't work. Whereas it could work the other way around. So let's make something that's really light, but really strong, and have something then which is, well, as long as it's got less strength, so it doesn't really, let's put 5, I don't know, and loads of weight, so 20. And then we put the strongest thing at the bottom, which is A, and that will then get squashed by B. Let's put the weakest thing at the bottom, but it can support A. Right, okay, there's bewilderingly easy examples to pick out. Anyway, suppose we have a safe packing order with item J directly on top of item I. Suppose further that Wj minus Si is greater than or equal to Wi minus Sa. Show that if we swap items I and J, we still have a safe packing order. Okay. Right, so we've got J on top of I to start off with. So we start with J, well, I don't need it on I don't use a line there, but j is above I. So we've got that. Then and that's safe. And then we swap these. So swapping is not going to put I at risk. Will not put I at risk. So that is okay. Then we've got, well, it doesn't affect anything above it or below it, or anything above or below, because they've all still got the same amount of weight on them. So we've gone from, so let's say we've got weight, let's say W, and then we've got weight J, weight I, and then, well, it doesn't matter what's happening below, but say we've got that. And then we've got, it doesn't matter about the strength at the top, we've got strength J and strength I. So say that's our initial setup. So what we're saying then is that, what are we saying? We're saying that SI must be greater than or equal to W plus WJ. So this W is capital W, is all of the weight above item J. So we've got that, and we know that SJ is greater than or equal to W. Then, so we need to show that we can flip these over. We need to be able to show that if we flip them over, that SJ is, so we're trying to show that SJ is then greater than or equal to W plus WI. That's what we need to show off of all of this. So how are we actually doing this then? I don't really know. I haven't used this equation yet that's in the setup. So we've got the, right, so SI is greater than that. SJ is less than, oh no, SJ would be greater than all of this thing as well. So how am I putting this together? I'm not really too sure how this is working. What are we trying to do? We're trying to show this. So we need to show that SJ is greater than W plus WI. Where's W plus WI coming into this? It's just not, is it? Well, we've got WI here, so that could be useful. What do we know about this then? So we're saying, so from here we've got the WI is less than or equal to WJ minus SI plus SJ. So that's come from here. So WI is less than that. So we can then say then, actually we might be able to get a chain going on here. Are we going to be able to get a chain of all of this? Because we've got WJ here. So what am I, right, let's try, I don't really know where this is going, but we've got W plus WI, that seems to be at the bottom end of a chain, but that's going to be less than, so if we replace the WI with all of this, which is bigger, so W plus WI is going to have to be less than W plus WJ minus SI plus SJ, because this bit here, the WJ minus SI plus SJ, is bigger than WI. So that's changed something. We've got that SI is greater than W plus WJ. SI is greater than W plus WJ. Right, so okay, so this bit then, that is going to be negative from here. So let's call that 1 from 1. So then we've got something negative plus SJ. So that must be less than SJ, which is what we want. SJ is greater than W plus WI. Right, therefore SJ is greater than or equal to W plus WI. Therefore, we can swap J and I. Geez. Right, okay, that was significantly more difficult than the first three parts of the question. Part 5, hence suggest a practical method of producing a safe packing order if one exists. Explain why your method works. Hence suggest a practical method of producing a safe packing order if one exists. Listing all possible orderings is not practical. So, right, this must be a follow-on from what we've done. So what have we shown? What have we shown so far? We've shown, well, part 1 didn't tell us anything. Part 2, so from part 2, that was saying we cannot pack based on weight. Part 3 showed us that we cannot pack based on strength. So that's ruled that out. What have we then shown then? Part 4 has shown that we can swap items if we've got this. If Wj minus Si is greater than or equal to Wi minus Sj. Right, wonderful. So what does that mean? So we can't pack based on weight. We can't pack based on strength. But it's got to have something to do with those. We can't do them individually. So what, are we doing them together? Is that what we're doing? It's got to be some combination of the two. We can't just have... Yeah, so what if we were packing on both? I mean, otherwise it's just completely random. And these are the only things we've got available. They can't be individual, so they've got to be together. So what if... So if we pack by... I mean, does it work if you add the two together? Did it work in this example? Yeah, it did. So let's do W plus S. So what would happen if we had W plus S? Then what? Then what do we do? Right, W plus S. If we pack by that, so what is that telling us? So it must be something to do with this swapping items. We can swap items if we've got that inequality holding. And that is W plus S if we swap them over. So this is actually Wj plus Sj is greater than or equal to Wi plus Si. So we can swap if we do that. Right. So we can always move the ones with the greater W and S to the bottom. Right, what are we trying to do? So we in part 4, we started with a safe packing order, and then we swap them around to move the heavier things to the bottom, and every step that we take, we get a safe packing order. Right, okay, right, yes, this is falling into place. Right, so so part 4 showed that if there is a safe packing order, we can sort items by moving items with greater W plus S towards the bottom. And that this also creates safe packing. Right, okay. Therefore, we can sort any, well, safe bag into order of lowest to highest W plus S from top to bottom. Yeah, so that will work. So therefore, pack highest W plus S at the bottom. Whoa, okay, that was the opposite of the previous question, as in they made the first parts really easy and the last parts really hard. So that's a tough question for number 6. If you have people going in there expecting you were going to get world famous logicians talking about hats and things they've written on each other's heads, then they're probably gravely disappointed. Interesting question though, but part 4 and 5 I think were pretty tough on that, but quite a nice one though.